Okay, today we're going to look at long division with polynomials, but before we do long division with polynomials, I want to remind you how we do long division with numbers. So remember, the first thing that you do is you're going to check and see, does 4 go into this number? Well, it doesn't, so then you're going to say, well, 4 does go, how many times does 4 go into 28? Well, 4 goes into 28 7 times. So then we do 7 times 4 is 28. And then we subtracted the 2, right? This goes to 0, and then we brought down our 7. And then we would say 4 goes into 7 once, and then we would do 1 times 4 is 4, and then we would subtract, so we would say this equals 3. And then you either did a few different things. You would either say remainder 3, right, or you would keep going, right, bring down more zeros, and you say 4 goes into 30, and then you would do a 7, and then 7 times 4 is 28. You subtract, and you bring down the 2, and then you'd keep going until either you got the number that stopped, or until you wanted to round to a certain decimal. So remember, we looked, how many times does this go into this number, put that up top, multiplied, and then we subtracted and then brought down a number. So we're going to do that same kind of thing with polynomials instead. So remember that when you're dividing, the dividend is the thing that you're seeing how many times something goes into. The divisor is the thing you're dividing by, and then your answer is the quotient. So you can have it either looking like these two where they're dividing, and then when you get the answer, that would be your quotient, or long division like this. So this would be our dividend, this would be the divisor, and then this would be our quotient, right? Oh, I forgot. The other way that you would write this is that you would write 71, and then you had 3 over 4. So you either wrote the remainder, the decimal, or you wrote it as a fraction. Okay? So when you are dividing polynomials, when you're long dividing polynomials, you have to make sure that they're in descending order. So the powers, the exponents have to be in descending orders. If you're someone who struggles a bit, I would suggest that you always put in any missing term with a x to the 7th, or whatever missing term it is, and then do 0x to the 7th. So a coefficient of 0 for any missing term. Okay. So what we're going to do, so notice here, these are all in descending order. 2, 1, none, and then 1, none. Right? So this is what goes underneath, right? We do our bar just like we did back in elementary school. So we put this underneath. I'm not missing any powers, so I have x squared plus 5x plus 4, and we're dividing by x plus 4. So the first thing that we're going to look at is we're going to say how many times does x go into x squared. So really off to the side you're thinking, well, it's x squared divided by x, which remember when they're dividing you subtract the exponents, so this is x to the first. So then you put whatever that answer is up on top. And you're only checking the first term on the outside with the first term underneath. So notice I didn't care about the plus 4, the plus 5x plus 4. All I cared about was the first term of each of them. Okay? So now we're going to multiply from here to here. So it's really like we're doing x times x plus 4. So if you're somebody who likes to put the box, then you would do a box off to the side, and you would have x plus 4 and x, right? So you'd get x squared plus 4x, or you can just distribute, right? So then we put our answer here of x squared plus 4x. Now, if you remember, back here, when we did this, we subtracted. What you're really doing is you're adding and then changing the sign. So right here, we're going to do that same. You didn't learn it that way in elementary school because you didn't know about positive and negative numbers, but you're really adding a negative number. So you change the sign and then you add the two things together. So we're going to do that same thing here, but when we change the sign, notice we have two terms that we need to change the sign to. So this is going to turn into a negative, and this is going to turn to a negative, and then we're going to add the two things together. So x squared minus x squared goes away. This is rigged that way. Anytime that you do this, the first term will always go to 0. You rigged it to work that way. So if it's not, then you did something wrong. So now we're going to do 5x minus 4x just gives us x, and I'm going to bring down the plus 4. Then we start that same process over again to do the same thing. So notice divide the first term by the first term of the divisor. That was this part right here, x squared divided by x. That's what we're thinking. We put that on top. Then we're going to multiply the divisor by the quotient. So this is divisor, that's the quotient, so I pointed backwards. Multiply those two, put that answer here. You're going to change the signs and then add everything together. Now we're going to do that same thing again. So I'm going to compare this into this. So off to the side we're thinking, what's x divided by x? Well, x divided by x is 1, so we're going to put the 1 on top. And it's a positive one, so that's why I put plus 1. So then we do 1 times both of these. So 1 times x is x, and 1 times 4 is 4. Okay. Then we change the signs, so this goes to a negative, this goes to a negative, then we add the two together. This goes to 0, this goes to 0, so both of them go to 0. So that means that our remainder is 0. Right? So this divides evenly. Right? So we're going to write the answer as x plus 1. Because there's nothing there. You could have, we could choose to write it the same exact ways as we had done, well, two of the ways if we had done here. Right? So we could write it as remainder 0, or we could do x plus 1, and then we have, notice whatever your remainder was, which was this part right here, and then over what we divided by. So we would have plus 0 over what we divided by, which is x plus 4, but in this case this is 0, so it doesn't matter. Right? So this is what you would get for your answer. Okay? So if we look at the next one, notice this is not in descending order. We have none, 1, 2, 3. It's in ascending order. So what we're going to do is we're going to switch around so it's in descending order. That's the one that goes underneath the divisor bar, the divide bar. So I'm going to rewrite it as 6x cubed minus x squared. Notice I'm taking the signs with me. Minus 5x plus 4. Right, and then on the outside goes the divisor, which is 3x minus 2. So we're going to start again. So off to the side, we're thinking, what's 6x cubed divided by 3x? Well, 6 divided by 3 is 2. And x cubed divided by x is x squared. So I'm going to put 2x squared up top. Now there are some people that make you put whatever power your answer is above whatever the powers that match. So like this is a 2x squared, so this would be 2x squared. So back up here on this one, some people are really particular and want the x above here and then the number above here. I personally don't care about that, but some people are very particular about that. So if you do this in another class, you need to make sure you know what the teacher's preference is and follow that accordingly. Okay. So here we're going to do 2x squared times 3x, which is 6. X squared times x is x cubed. Then I'm going to do 2x squared times negative 2, so 2 times negative 2 is negative 4, and then we keep the x squared. Okay. But now we need to change the signs. So we divided the first term, we multiplied everything, and we're going to change all the signs and add together. So this goes to negative, this goes to positive, and I'm adding the two together. This first one will always go to 0, unless you did something wrong. So you have negative x squared plus 4x squared is 3x squared. I'm going to bring down the rest of them. So now I'm going to repeat that same process again. So I'm thinking 3x squared divided by 3x. Well, 3 divided by 3 is 1, and x squared divided by x is x. So this is really 1x, which is just really x. So I'm going to times by x. So I'm going to do x times 3x is 3x squared. X times negative 2 is negative 2x. Again, we're going to change the signs. I change the sign here, change the sign here. I do like to do my long division with 2 different colored inks so that I can, or obviously this is pen and pencil, but so that I can tell my plus and negative signs. So that may be something that you want to try on your homework tonight. So these you're going to subtract. so this goes to 0, which is what we wanted it to do, and then this is negative 5x plus 2x is negative 3x, and then I'm going to bring down the plus 4. So then we're going to do the same process again. So we're going to have negative 3x, so again off to the side we're thinking negative 3x divided by 3x, so this will give us negative 1. Okay. So I'm going to move this up here. So we have negative 3x plus 4. And we're timesing by negative 1. So we're going to do negative 1 times 3x is negative 3x, and negative 1 times by a negative 2 is positive 2. Again, we need to change the signs. Change that to a plus, this to a minus. This goes to 0, and then 4 minus 2 gives us 2. I know I'm done here because if we look, 2 and 3x don't go into each other. So see, this is really 2x to the 0. So this power is lower than this. So anytime the one that you're working on has a lower power than your divisor, then this is just your remainder, right? So now my answer is going to be this, and then plus our remainder of 2, and then we write over what we divided by. So we're going to always choose to write it as put the remainder over what you divided by. So to make it look nice, we're going to write it over here. So 2x squared plus x minus 1 plus 2 over 3x minus 2. So this polynomial, the 3x minus 2, does not go into 6x cubed minus x squared minus 5x plus 4 evenly, right? Meaning that there's a remainder. Okay. So we're going to look at this next one. Again, these two we had divide these two and divide this by this, and then this one we have it as a fraction, right? So there's different representations that you can do with this. So